That's Stray's tutoring? Hey guys, welcome to today's video. We'll be going over the atmospheric layers. The Earth's atmosphere is made up of distinct layers, each with a unique characteristic and, certain roles. Starting from the ground up, we have the troposphere where all weather occurs. This is something that we're all very familiar with. Above its line is the stratosphere, home to the protective ozone layer that everyone is talking about and crazed about when it comes to climate change and its depletion. Next is the mesosphere, which burns up meteors and, one of my favorites if you ask me. Next is the thermosphere, where you have the northern lights dance. And finally, the exosphere, where we merge into space. These layers shield life on Earth, regulate climate, and protect us from harmful solar radiation. Together, they form a dynamic system essential for life as we know it. So in this video, we'll go over each of these layers. We'll go over some key facts and why they are so important. So let's jump right into it, guys. Key facts. Earth's atmosphere. We can see to our left, we have many of them labeled. Of course, the troposphere, stratosphere, mesosphere, thermosphere, and it's not shown there, but the exosphere. Now, what are some key facts? Well, the atmosphere is comprised of layers, which vary in temperature, composition, density, and they play a crucial role in supporting life on Earth. So if you haven't already, make sure you guys thank your atmospheric layers for protecting us and all of our life. I mentioned in the Carboniferous era where the oxygen levels were at 30%. As of today, the atmosphere is actually 21% oxygen, 78 nitrogen, and then there's other gases that are involved like argon, carbon dioxide, water vapor that make up very small amounts. So as I mentioned before in the beginning of this video, the troposphere is the lower layer. The stratosphere is where the ozone layer is, and I'm kind of going quickly over this because we're going to go over each of them individually. And then the mesosphere is where meteors burn up upon entering the atmosphere, and it actually is the coldest layer, quite surprisingly. Thermosphere, you can reach extremely high temperatures, low density, and this is where it also contains the ionosphere, which is not on this chart, but this is where where radio communication occurs. And then of course, exosphere is the outermost layer where we can escape into space, and that's where a lot of the satellites are. So if we start with the troposphere, let's get a bit more detailed here. So the troposphere, again, is the lowest layer of Earth's atmosphere. It's where all of the weather happens, like rain, snow, and a lot of the storms. And this is where a lot of the water vapor is held up, hence why you see a lot of weather activities here. It's about 16 to 18 kilometers thick, and the temperature decreases steadily as altitudes rises. This layer is capped by the tropopause. Yes, the tropopause. You can see what we're doing here. Troposphere, tropopause. A boundary that limits weather activity and marks the beginning into the stratosphere. The stratosphere is located right above the troposphere. It extends about 15 to 50 kilometers above the Earth's surface. And the temperatures here rise with altitude due to the ozone layer. So what is the ozone layer? It absorbs harmful ultraviolet radiation and protects life below. So this ozone-rich region, which you'll see some chemicals pop up here, O3, it acts as a shield against UV rays. Although it contains far fewer greenhouse gases than the troposphere, a lot of human-made emissions called CFCs damage the ozone layer and they create these holes. So a lot of times we talk about ozone depletion, but rather they're actually holes that are being created in the layer, and that increases UV exposure. And this is where we go into climate change, where the ozone layer is depleting or thinning, allowing more UV rays to be trapped on our Earth and warming up the Earth, which thus causes extreme temperatures, extreme storms, and then the melting of a lot of our ice caps, of course. So What are some greenhouse gases? These greenhouse gases are carbon dioxide and even methane. So these have very significant warming effects in the lowering layers. Overall, the stratosphere is one of the most important just because it contains ozone layer, which again is here to protect us. So if we go into the mesosphere, this is the third layer of Earth's atmosphere, and this stretches around 50 to 85 kilometers above the surface. And its temperatures drop sharply with that altitude. I think you guys can kind of see the pattern here. So it reaches the coldest temperatures in Earth's atmosphere as low as negative 90 degrees Celsius or negative 130 degrees Fahrenheit. The mesosphere lacks greenhouse gases to trap heat, causing temperatures to decrease with height. So this layer is also where most meteors burn up upon entering Earth's atmosphere. And it usually creates like these shooting stars that can be visible from the ground. But, the mesosphere is too high for weather and too low for orbiting satellites. So it plays a crucial role in atmospheric chemistry and, protecting the Earth's surface from meteoroid impacts. The air is extremely thin here, but it has a lot of strong winds, atmospheric tides that create waves that help mix the atmosphere and influence weather patterns in actually the lower areas. Next, we have the thermosphere. The thermosphere is the fourth layer of the Earth's atmosphere, beginning around 85 kilometers to 600 kilometers above the Earth's surface. That is insane. So the temperatures here can soar to 2,500 degrees Celsius or higher due to absorbing the intense solar radiation, particularly like high energy X rays and UV rays. But despite these temperatures, the air feels cold. Like, how's this even possible? Well, this is because the atmosphere is so thin with few molecules to transfer heat. So even though it is getting this high temperature, you really don't feel that heat. It's actually very cold. So it's kind of weird here. This layer contains the ionosphere, a region filled with charged particles that reflect and influence radio waves, making long distance communications possible. The thermosphere is also where the auroras, or the northern and southern lights that you see in the night sky, as charged particles from the sun interact with the Earth's magnetic field. Satellites and the ISS orbit within this layer due to the low air resistance, although they still experience quite a bit of drag. But nonetheless, this is where their home is. So overall, the thermosphere is a crucial layer that absorbs solar energy and protects Earth from harmful solar radiation, and also plays a huge role in communication and space exploration. Lastly, we have the exosphere. This is the outermost layer of Earth's atmosphere. And of course, look at that, how far it extends out, around 600 kilometers to 10,000 kilometers. And this gradually merges with outer space. So in this layer, the gas molecules are extremely sparse and they can travel vast distances without colliding. So it almost kind of creates a vacuum environment. The temperatures here are very high due to solar radiation, but since the particles are so spread out, there's very little heat transfer. So it feels cold to us when we're up there. So, wow, if we're going this high out and we're getting exposed to radiation, UV, you'd expect it to be hot. But it's not. It's cold because, again, a lot of the particles are spread out. And when particles are spread out, there's not too much heat transfer. But when particles are close together, there's a lot of heat transfer. Therefore, we feel like it's cold up there. So how about, as far as elements? Well, the exosphere contains mostly hydrogen and helium atoms. And there are some traces of like heavier oxygen and carbon dioxide, but for the most part, it's hydrogen and helium. Satellites orbit here with virtually no air resistance, and particles may even escape Earth's gravity, drifting into space. So the exosphere really marks the transition between Earth's atmosphere and the emptiness of space. So it kind of acts as a boundary that fades into the vastness beyond, that pitch black that we see. So guys, these are the atmospheric layers. I think I did it in under 20 minutes. So just make sure you guys go back to the video, take down some of the key details, and I hope you guys enjoyed, and I'll see you guys next time. Peace.